In this section, we're going to discuss the idea of super and subclasses and their relationships. When a set of related classes is designed, the common parts amongst those classes should be put in the superclass. That's the idea of the superclass, is to be a common set of functions and data that all the related classes will have and use. Superclass doesn't mean more powerful. It means above. Think of the superclass higher and it flows down into subclasses. That's generally the way they're drawn. The subclasses actually have more power than the superclass. So the word super, again, is from the Greek, and it means above. These subclasses have access to all the non-private, the superclass data and methods, and add additional data and methods so that the subclass knows and does everything the superclass knows and does, plus it can do more. Assume a set of geometric objects that are going to be drawn on a window on your screen, a game or something like that. Each object would have certain common attributes. The drawing color, whether it's filled or not filled, creation date, other things you could definitely put in there. These are abstracted out of each of the objects and put into the superclass because they share the same information. Again, drawing color, creation date, filled or not. Some common behaviors on these objects would be computing perimeter, area, etc. But at this point, it becomes complicated because the superclass cannot have a generic method for determining the area of an object. A circle's area is determined very differently than a rectangle's. The circle and rectangle class have to have their own specialized code for computing the area based on its type. A circle has a radius, a rectangle has length and width. They don't share those in common. So again, those have to be specific to the circle and rectangle classes themselves. That cannot be in superclass. Although the superclass can have the idea that the area must be computed, it just cannot say how. The book defines a geometric object class. I like the term shape better. That's what we tend to use, and it's shorter. This is the superclass, and it will have the method and data members common to each subclass. Since the subclass will know and do everything the superclass does, the subclass is considered the superclass plus more. We say it is a superclass. Because it knows and does everything, it acts just like the superclass, only it can act and know a little more. The reverse is not true here. The superclass is not a subclass. The superclass does not know and do everything the subclass can. So the is a relationship flows downward from superclass to subclass, not upwards. It may be surprising that private superclass members are not shared, even though they're defined in the superclass. And I said that a subclass knows and does everything superclass knows and does, except for private members. Although they're technically defined, they're just not directly accessible. We don't want to overcome this limitation by declaring everything public, because then external code can see all of the data members, which is something we want to avoid. The circle class inherits the geometric object data members and method members by using the extends keyword. That's how Java implements this inheritance concept. The subclass extends the superclass. In the book, the circle class defines some overloaded constructors and other methods that focus on circle-specific behaviors, dealing with radius, area, perimeter in the way a circle would do it. Now, the subclass circle will have color and filled members available to it from the superclass. But again, since they're declared private, they are not directly accessible but must be accessed through this superclass's accessor mutator methods. Those accessor and mutator methods are defined and are available on the circle object, so it can just simply directly call those methods. The time saving occurs because the circle class does not define a getColor or getFilled method. It uses the superclass version of them. So this allows us to make specialized classes like circle that focus on circle related things without having to repeat the common stuff in the superclass. The subclass extends the superclass and gets the getColor and getFilled methods because of that. It is possible for a subclass to directly access superclass data and members by using the protected keyword instead of private. There are some good reasons not to do this though, so I will continue to teach only private and public and follow the book's example in doing so. Inheritance is powerful, but it is prone to misuse. Some programmers tend to use it simply to save keystrokes. Easier to use, but it doesn't make sense. What has to be done is hard thinking to make sure that each superclass represents the common behaviors of all the related subclasses, and that each subclass must be a specialization of the superclass. The subclass is a superclass. It has to have that relationship. Otherwise, this time saving is going to cost a lot later on. The book's example about not extending a rectangle to make a square is, I believe, a bit misguided. A square is a rectangle. There's nothing about a rectangle that a square isn't. But a square is a little more specialized in that its height and width are identical. That doesn't mean it's not a rectangle. It just means it's a rectangle whose side for height and side for width are the same. That's not a problem. The problem is trying to go the other direction, trying to say that a rectangle is a square with sides of different lengths. That does not make sense. So this is a good example of testing your idea of is a square a rectangle? Yes. Is a rectangle a square? No. And again, the reason the rectangle is not a square is because it takes an inherent quality of a square, that is, the sides are equal, and changes it. Fundamentally alters the understanding of square to develop a rectangle. But square being a rectangle, or square is a rectangle, doesn't change anything. It just adds a slight restriction that says the height and width must be the same. That does not violate anything about a rectangle. It just specializes it. Generally, rectangles can have different heights and widths, but they don't have to. So the lesson here is one must be very careful in developing superclass subclass relationships and always ensuring that the subclass is a superclass plus some more.